So yeah, we are discussing about finding the value of VTH and RTH. So how we'll calculate the value of a VTH and RTH? So this is your question. It's given 2I, particular 2I is given, that is 1 ohm, 2 ampere current is flowing in this circuit. So you need to calculate the value of VTH and equivalent resistance. So this is your VTH only, VAB only, this particular, this is your VTH only. So if you want to calculate the VTH value, how you will do it? So I am just taking this is my V. So if I am taking this particular is my V, so by applying the nodal analysis, what I will get? V minus 2I divided by 1 plus V by 1, okay, minus 2 ampere current plus V divided by 2 is equals to 0. Okay, and what is the relation between this V and I relations? So this is the value of I is given. So what is the relations? V minus 0 divided by 1 is equals to I. So your V is equals to I only. So instead of I, we can write like V minus 2V plus V minus 2 plus V by 2 is equals to 0. So after solving this, what we will get? These things will get cancelled out. So we are getting V value as 4. So VTH value it's coming as a 4. Okay, VTH value will come 4. What about the RTH value? So for finding the RTH value, na, so suppose you need to calculate the RTH value. Let me take. You need to calculate the RTH value. So for finding the RTH value, your independent source will become open circuit. Means this is the current source, so this will become open circuit. Your current source has been open, but your dependent source will be remain there. Okay, dependent source will be remain there. Now for finding the value of RTH, here the thing is that we have I value, so we have to assume one test source voltage. Okay, this is our test source voltage. This I am assuming as a 1 volt. Okay, and I am assuming one current I, this particular I current. So for finding the value of RTH, what you need to do? V is equals to IR. That means 1 divided by this I value. You have to calculate this particular things. So how you will do it? This is 1, that means overall voltage here it's a 1 volt only. This is 1, so that is 1 only. So apply the nodal analysis and get the results. 1 minus 2I upon 1 plus 1 by 1 plus 1 upon 2. Okay, this 1 upon 2, and you are taking this as a I value. This will be your I value. Okay, what is the relation between 1 and I? So 1 minus 0 is equals to I divided by 1. So I is equals to 1. So substitute this and get the results. So 1 minus 1 minus 2 plus 1 plus 1 by 2 is equals to I. So how much you are getting? How much you are getting? This particular I value. 1 minus 2I plus 1 plus 1 by 2 plus 1 by 2, 1 by 2, and this is equals to your, this particular is equals to, you are assuming this current. So you have taken this current, this current, this current, all are outgoing currents, but you have taken this particular I value. So I value you are getting as 1 by 2. So what will be the RTH value? RTH value is 1 divided by I. So RTH value will be 1 divided by 1 by 2. So 2 ohm. So RTH value will be, RTH value will be how much? It will be 2 ohm. So understood this question how to solve? This was the yesterday problem question, so you need to solve like this. Okay, so yeah, let's move to the next topic. Before moving to the next topic, you just try this question. We had completed this part. So we solve this question, right? This question we solve. Now you have another question. Just try by yourself. Oh, wait. Just give me a 2 minutes. It's again stop working. Just give me a guys 2 minutes. So what I was trying to give you, so this particular is your one circuit, this is 1 ampere, okay, and this is positive, negative 0.5 I, and this is 5 ohm. Okay, now you need to find VAB across this. Okay, this is 5 ohm, this is positive, negative.
Sir,
Yes,
screen is not visible, sir.
screen is not visible.
Yes, sir.
Is this visible?
Okay.
Yeah. So what I am telling, you need to calculate the value of VAB. So Priyanka, how you will calculate this value VAB? You need to calculate the value of a VAB. So this is your question. How you will do it? So just simply means this, if you will assume this particular VAB, so this VAB will be equal to this VAB, because this is parallel connected na, this particular point is parallelly connected. So apply the nodal analysis. So by applying nodal analysis, so what you will get, VAB by 5 plus VAB minus 10 upon 5, and one current is coming as a 1 ampere. Okay, so what the result you will get, 2 VAB minus 10 is equals to 5, so VAB is equals to 15 by 2, that is 7.5 volt. Okay, so this is this, yeah, this is one way to calculate, means you got the value of a VAB. And yeah, here in the question it is mentioned the I current, this particular is your I current. Now you need to find the, you got the value of a VAB you got. Now you need to find the value of a RTH. Okay, RTH. So for finding the value of a RTH, what you will do, you will open your circuit, positive, negative, 0.5 I will be remain there, but this circuit will get open, 0 ampere. Okay, this will be 5 ohm, this will be 5 ohm, and here it's given as positive, negative. So just wait. So your dependent source will be get eliminated. This will be 5 only, this will be 5 ohm only, and this circuit will get short circuited, because in a Thevenin's dependent source, if the voltage is there, it get short circuited. Now in between VAB, because I have a test source, but this test source is not going to be used because it's only opened. So this is your, you have to see your R value from here. So it's already open, so there is a no use of that this test source, so you are directly getting the value of R between this is also 5, this is also 5, so both are parallelly connected. RTH will be 5 into 5 divided by 10, so how much you will get, 2.5 ohm. Okay, Priyanka, is this clear? So you will get 2.5 ohm in this particular network. Okay, so you are getting the value of 2.5 ohm. So this was the circuit. You use the nodal analysis, you got the 7.5 volt. Here you use the RTH value. So for this, because here we having a current source and this getting open circuited here automatically, so there is a no need to do anything. So it will automatically, it will be 0 ampere. So from this, 5 into 5 divided by 10, you are getting 2.5 ohm. So this circuit is also clear. Now I am giving you another question for finding the Thevenins. Just wait. So see, yeah. Now you have a question. You have a question. You have to develop the Thevenin's equivalent circuit between terminal X and Y. Develop the Thevenin equivalent circuit. Okay, so what is the circuit? Your circuit is like this: positive, negative, it's 0.5 I. This particular, yeah, here 1 ampere it's given. Okay, and here it is 5 ohm, and here it's given 5 ohm, and your I current is this, positive, negative. This is your 10 volt. Now you need to find the Thevenin's equivalent bit XY across this VXY. So how you will do? How, guys, how you will do it? So guys, this is your question, and so it's not coming. Okay, so you have this particular question. Now you need to calculate the Thevenin's equivalent across this. So this is your VTH. So apply the nodal analysis and get the value for this particular VTH. This VTH is nothing but it's equal to 0.55. If you are taking the reference value, so VTH minus 0 is 0.55. So VTH is 0.55 only. So I am taking some V point here. Okay, this I am considering some V point here. So apply the nodal analysis. If you will apply the nodal analysis, what you will get? 1 ampere current will be V by 5 plus V minus 10 divided by 5. So 5 is equals to 2V minus 10. So V is equals to 7.5 volt. Okay. What is the relation between, you got the V value, what will be the I, small I? A small I will be V minus 10 divided by 5. So V is 7.5 minus 10 divided by 5. So a small I will be minus 2.5 divided by 5. That will be 1 by 2. Means 1 by 2 is minus 0.5 volt you are getting, a small I value. So what is your VTH? VTH relation we got 0.5 into I. So we are getting 1 by 2 into I is minus 1 by 2. So that is minus 1 by 4. it's coming 0.25 minus 0.25 volt. Okay, so you got the VTH value. Now you need to find the RTH value of this circuit only. So for finding the RTH value, this is your independent source, positive negative 0.5 I will be there only, and your current source will be open. So this get opened directly. Okay, now this is your 5 ohm, and this particular is your 5 ohm, and this will get short circuited. Okay, and this here you having a test source, so I am just assuming the test source value as a 1 volt and current I. So you need to find the value of this particular current I. Okay, so guys, I value, small I value was this one only. So there is a nothing, no source is there. That means your I value is 0. No voltage is here. If you will see this particular circuit like this, no voltage, nothing is there. So current will be 0. If the current is 0, this current is 0, that means your 0.5 into I will also be 0. So what you are getting? You are getting like this. Circuit like this. So 1 volt. And this is your I. So means yeah, you are getting like this. So what will be the resistance? What will be the resistance? Resistance, there is a no resistance because this things is 0, so RTH will be 0. Okay, so how you will represent the circuit? Positive negative minus 1 by 4, RTH is 0. So this will be the answer for this circuit. Okay, so guys, now you have one question, so just try to solve this question. Question is, when complex network N is connected to the load resistance RL, the power dissipation is P naught. When two such identical complex network N are connected to the load resistance, connected to the load resistance RL, the power dissipation will be the power dissipation will be dash. So option A is P, option B is 2P, option C is 4P, option D is P to 4P. So what will be the answer? Means suppose you have a complex network like this, one complex network, okay, it's having a load resistance RL. Okay, now means in this case they had said that the power is P. Okay, P naught or P, whatever you just want to take. Now they are saying that when two complex network like this, when two complex network like this, it's connected to network, then this RL, new power will be P new will be what? Okay, so guys, suppose this network and this network are identical. I am assuming this particular network as VTH, RTH, this is my RL. Okay, so what will be the I current? I will be, I am just taking I am just talking about these things. Okay, first figure, when the power was P, so I will be VTH divided by RTH plus RL. Okay, and power will be P will be equal to I square into RL. So power what you will get? Power you are getting as a VTH is VTH divided by RTH plus RL the whole square into RL. Okay. So guys, suppose you have means they are now the circuit is becoming like this. You have RTH this side also, and you have RTH this side also. Both had connected with RL load. You have the same VTH here also and the same VTH here also. Okay, so if the thing is like that, then how can you do this circuit? How can you do these things? Means how you will solve these things? Okay, okay guys, so now you will calculate your new Thevenin's equation, new Thevenin's equations across what? Across this AB point, across this AB point. So if you are considering your new Thevenin's equation across this AB point, so new circuit will be like RTH, this is your VTH, positive negative, this is your RTH, and this is your positive negative VTH. I just opened this. Okay, you need to calculate the V value, your VTH dash value across this. So what will be the overall current in this? Minus VTH plus I into RTH plus RTH. Okay, plus VTH minus VTH plus like that. If you'll solve it, so you will get is equals to 0. So these getting cancelled out, so you will get to know that I value will be 0 because the same value it's coming, same value, so I value will be 0. If I value is 0, apply the nodal analysis like this. If you'll apply the nodal analysis, I value is 0, then VTH dash will be how much? VTH dash will be equal to minus VTH dash, means if you will apply the, if you'll applying the nodal analysis like this, so VTH dash will come how much? Minus VTH plus 0 RTH plus VTH dash is equals to 0. So VTH dash is coming as a VTH only. So you get the value of your new VTH. What about R equivalent? Your new RTH. So for new RTH, this will be RTH, this RTH. So you are seeing from this particular VTH dash. So it's parallel, both are parallel. So your RTH dash is RTH by 2, your new RTH. So you got the equivalent circuit of this particular circuit is RTH by 2, and this particular is positive negative VTH only, and this is your RL network. So what will be the I, current I? Current I will be VTH divided by RL plus RTH by 2. Okay. And what about the means if you'll go means if you'll do like this, yeah, if you'll do like this, so what the current you will get? I is equals to 2 VTH divided by 2 RL plus RTH. So what the power you will get? Power will be I square into RL. So that will be 2 VTH divided by RTH plus 2 RL, 2 RL square into RL. So this is your new P. And if you will compare with your old P, what was the old P value? VTH by RTH plus RL the whole square into RL. Okay. So just compare this two and compare your option. Your option is P. So it won't be a P. Your answer will, it won't be a P. Okay. Okay, it won't be a P value because this is not equal to this P value. Even if your RL value is 0, if you'll put the RL value, if you'll not, means the RL value won't be a 0. Means suppose you are considering your RL value as a 1. If you'll put the RL value as a 1, you will get VTH divided by RTH plus RL the whole square. So the value will be fluctuate. Okay, the value will be fluctuate between P to 4P, between P to 4P, P to 4P. Okay. Suppose, yeah, the value will be fluctuate. It won't be the same because you are getting the result like this. One value is VTH divided by RTH plus RL the whole square into RL, and another is the multiplication of 2. See, the power is coming 2. This particular is coming 2. Okay, just take it as a common. You will get 4 VTH square divided by RTH plus 2 RL into RL. Okay guys, means for solving this kind of a question you have to do like this, and you have to compare the things. Okay, you have to compare the things. Like now means you cannot put 0. If you'll put 0, the overall power will become 0. Overall power. Okay, like put the value of RL in both the equations 0. You will put the RL both the equations, it will also be 0, it will also be 0. Now put the value of power as means RL value as a 1. If you put the RL value as a 1, you are getting 4 VTH square divided by, and assume something, your VTH, you assume you assume 2 volt is your VTH. Okay, so VTH will be common for both. So you are getting how much? If you'll substitute it for 16 into RL divided by RTH plus 2 RL, and here it will be 4 into RL divided by RTH plus RL. So if you are putting the value of a RL, means you are taking the RL value as a 0. If you took the value of a RL as a 0, you will get 0 0. Okay, now if you are taking the RL value as a 1, you are getting how much? And suppose your RTH value is 2. If you are taking the RTH value 2 here, there will also be a 2. So you are getting the value of how much? 16 into 1 divided by 2 plus 2 4. RL value you are taking 1, and RTH value, yeah, so 16 by 4 is coming. And here how much it will come? 4 into RL value you assumed 1 divided by RTH value was 2 plus 1, so 4 by 3. Here 4, here 4, so means 4, or it's 4 by 3. So your value is not fixed. See, your value is not fixed, so that's why we cannot select P, 2P, 4P. The value will fluctuate from P to 4P. Okay, so how we did this question? We we solve the network. We solve the network means like a network is this. So this network means what? Networks having some particular VTH value, and it's having some RTH value, and another network is coming across this. Then what will be the power? What will the power, they are asking? So okay, for this network I am getting the current I is equals to VTH divided by RTH plus RL. Power will be VTH, means I, equation of I got it, VTH divided by RTH plus RL. I put the equation, so we got it. Now if you'll substitute both the network will get the network like this. Okay, now we need to find the new VTH and RTH. So by solving this is the VTH only, this is the VTH only. So we get to know that overall current will be 0, and we need to find the voltage across this. That's why we opened it. Okay, so now if I'll find the, means I am getting the I value as a 0, VTH into IRTH. So I got the value of a VTH dash, means this new voltage is same. Now you need to find the RTH value of this circuit. So these RTH value, this is here RTH, and here it is RTH, and we are seeing from this part. So this RTH is coming as a RTH by 2. So this circuit can be represented like this. Okay, now find the value of a current. You got the current value as VTH divided by RL plus RTH by 2. By solving this, you get this 2 VTH divided by 2 RL plus RTH, and you put the equation in the form of the equation. So you get what you got. You are not getting any constant term, either it's getting doubled or tripled. So it will fluctuate from one point to another point. So that's why we put the value. We just assume some VTH value as a 2 volt, and put in the equation. So what we are seeing, that the power is getting increased, means it's getting increased. Okay, is this clear to everyone? Is this clear to everyone? Prasanna, is this clear? Prasanna, is this clear for you? Priyanka, is this clear for you? Or still having any doubt?
Yes, sir. Yes, sir.
Okay. Okay. If it's clear, then it's fine. Okay. So, so Thevenin's is almost done. One question is there, just try it. Wait, just wait. Yeah, so we had completed these things. Okay, so one question is there, means just try. What is the question? I am just saying, I will not write. See, 1 ohm resistor is connected across the battery charges. Okay, so it is given 1 ohm resistor is connected across the battery charges. It derive a current of a 5 ampere. So suppose here it is some battery. I am taking it as a VTH, and 1 ohm resistor it is connected across this. Okay, 1 ohm resistor. Okay, and it derives a how much current? It's given 5 ampere current. Okay, so battery can be replaced, means when 1 ohm resistor is connected across the battery charges, it derives a current of a 5 ampere through a resistance. And when an ideal 2-volt battery is connected across the same battery charges its charges to ideal battery with a current of a 7 ampere. Okay, so suppose you have to think like this. There will be one RTH. So this is your equivalent circuit of internal battery, means VTH and RTH is given, and when it will be connected to 1 ohm resistor, it will have 5 ampere current. When the same battery, means VTH and RTH will be same, when it will be connected across not across 1 ohm voltage, means they had given this battery is connected to some 2 voltage source, 2 voltage source, then its current is 7 ampere. Okay, it's given like this. Ideal 2 volt source, if it is connected, if the battery charging is connected to 2 volt battery, so means find the current flowing through a 11 ohm resistor connected across a terminal of a battery. Means they are asking you when it will be connected to 11 ohm, so what will be the current? Okay, see, battery charges means they had given a battery charges. Battery means suppose you have some battery like this. Okay, and this battery is charging means it's having a some current when it will be connected to, suppose this is connected to 1 ohm resistor, then it will charge, means like a 5 ampere current will flow. So these particular battery can be replaced like this: VTH and RTH. Okay, same battery, if the same battery is connected to 2 volt source, positive negative, so it will deliver a current of a 7 ampere. When this battery will connected to 11 ohm resistor, they are asking the current. So you understood what is the meaning of a question? Okay, so how you will find this? So guys, just form the equation. VTH will be 5 RTH plus 5, one equation. Okay, form another equation. VTH minus, this is 2 volt, VTH minus 2 volt divided by RTH is equals to 7 ampere. So VTH minus 7 RTH is equals to 2 volt. Now you have equation 1, equation 2. You can find the value of a VTH RTH, right? You can find the value of a VTH RTH. VTH minus 5 RTH is equals to 5, and VTH minus 7 RTH is equals to 2. positive, negative, negative. So what the value you will get? 2 RTH is equals to 3. So RTH value is 3 by 2. Put the value and get the value of a VTH. VTH will be 2 plus 7 RTH. So VTH value will be 2 plus 7 into 3 by 2. So how much you will get? 21 is 25 by 2. So VTH will be 25 by 2. Now you have VTH. Now you have RTH. If you will connect 11 ohm resistor, what will be the current? So I will be VTH divided by RTH plus 11. So VTH is 25 by 2 and RTH is 3 by 2 plus 11. So what value you will get? 25 divided by 12, 22 plus 3. 22 plus 3 is 25 only. 20 by 2 will get cancelled out. So you will get 1 ampere. So current will be 1 ampere. Prasanna, got this? Understood? Prasanna,
Yes,
understood? Priyanka, you understood? See, question is means like they had given one, suppose one network. Think like that. Means if they are saying like the one battery is charging 5 ampere current when it is connected to 1 ohm resistor. So battery can be replaced like this VTH and RTH. The same battery when it will be connected to a 2 volt. So this VTH and RTH will be connected to 2 volt. It's having a current of a 7 ampere. Now you have a two circuits with the same variables. By using the KVL, you can get the value of a VTH and RTH. Now what they are asking, if the same battery is connected to 11 ohm resistor, what will be the current this will derive? Means how much current it will derive. So you got the value of a VTH, you got the value of a RTH, put the value in this and get the result of I. Understood?
yeah.
Okay. Now we had completed our Thevenin's theorem. The next topic is Norton theorem. Okay, so there is not much different in Norton theorems. We had completed superposition theorem, we had completed Thevenin's theorem. We are going for a Norton theorems. Okay, so Norton. This is your Norton theorem. So linear bilateral network, same thing, same principle. So this is your linear bilateral network. This particular is your load and some current is flowing means in this network. Okay, so it's have positive negative VSK. This is your load, linear and bilateral or linear and bidirectional circuit. Okay, linear bidirectional circuit. This is your IST. So this particular is your network. Okay, this is your network. So it can be replaced in this way: one current source and one Rn, and whatever the load resistance, it will be parallel to this. So this particular means your load resistance, so this will get parallel. to this. Okay, this is your Norton currents, IN. So write it down. In two terminal network Na containing linear and bidirectional linear and bidirectional elements and independent sources can be replaced by a simpler network containing an independent current source. Okay, IN. That current source is IN connected with parallel RN. Connected with parallel RN. Okay. So suppose you have a network. So now suppose you have a network of a 2 ohm and this is your 4 ohm, and you have 6 ohm resistor here, and here it is given 3 ohm, and this particular is your 5 ohm. Now its current is given 20 ampere. Okay, so suppose, yeah, this is A, this is B. You need to find a Norton equivalent in this parameter. This 5 ohm, suppose this 5 ohm is your load resistance. This particular is your load resistance. It is your load resistance, RL. So how you will solve this circuit? So for finding the Norton's equivalent in a Thevenin's equivalent, we do open circuit, okay, across AB. But in a Norton equivalent, what we will do? We will do short circuit. We will not do open circuit. We will just merge this A and B because we need to find the IN current, okay, and this load will be shorted, and this is your 3 ohm, this is your 6 ohm, this is your 2 ohm, this is your 4 ohm, and this particular is your 20 ampere. So guys, you need to find the value of IN. How you will find it? How can you find it? So see, I'm giving you one. Suppose means if you have a circuit like this. Suppose if you have a circuit like this. This is 20 ampere, and this is 4 ohm. So this circuit can be replaced like this: positive, negative, 80 into 4 ohm. This circuit can be replaced like this. So this head terminal you have to positive, and the tail terminal you have to assume negative. What is the single resistance? Means between this kind of a circuit can only be replaced like this. So 20 into 4, 80 volt. 20 into 4, 80 volt. And what is the resistance? 4. So you can, I'm just giving you one result. So you can make this part, this particular part, like this also, okay, for calculations. So if you will do it, or otherwise you can apply the nodal analysis and you can solve it, you will get the same answer. Okay, let, I am using this 4 ohm. I will show in a both way. 80. So we make this particular things like this, and this is 2 ohm, this is 6 ohm, this is 3 ohm, and you need to find this IN current. So assume V. Now the calculation will be very easy. V minus 80 divided by 6 plus V by 6 plus V by 3 is equals to 0. Multiply and get 6 here. So you are getting 2 plus 3, 3. 4V is equals to 80. So value of a V you are getting 20 volt. So if you are getting the value of a V is 20 volt, so your IN will be 20 divided by 3 ampere. Okay, so you will get the IN value as 20 divided by 3 ampere. And suppose if you are doing like this particular things like this, you are assuming V1 value here, V2 value here, so you will get the same, but you have to solve many equations, like 20 ampere is coming is equals to V1 by 4, that is V2. V2 by 4 plus V2 minus V1 by 2. So 80, 3V2, 3V2 minus 2V1. One equation you got. Now solve in another. V1 minus V2 by 2 plus V1 by 6 plus V1 by 3 is equals to 0. So 3V1 minus 3V2 plus V1 plus 2V1 is equal to 0. So 3V1, 6V1, 6V1 is equals to 3V2. So the value of you need to find the value of a V1. So this, so V2 value is 2V1. Okay, put the value in this. V2 value is 2V1. So 80, V2 value is 2V1. 2 V2 value is 2V1. So get 6V1. 6V1 minus 2V1. So 6V1 minus 2V1 will be 4V1 only. Okay. So 6V1 minus 2V1. So V1 value you will get 20. So if you are getting the V1 value is 20, 20 divided by 3. So you are getting the IN value same. So this is very simple now. You need to do so much calculations. And if you know the result, means this particular things can be make it like this. If you know this result, you can make a very simple calculation. It will be a very simple calculation. So try to do like this. Don't make too much complex like this. Okay, otherwise you will get the same result only. So our aim was to find the value of IN, and we got the value of IN as 20 divided by 3. Now you need to find the value of RTH. So for RTH the same concept. For finding the RTH you don't have to do any other things, further things, or you just this is your dependent, this is your independent current. So independent current will be opened. This is 4, this is 2 ohm, this is 6 ohm, this particular is 3 ohm, and this part you had short circuited, so you are seeing from here. Okay, so this 4 and 2 will be 6, this 6 and 6 will be parallel, and this 3. I was saying from this. So 6, 6, parallel will be 3. 3 plus 3 will be 6. So RTH you will get 6 only. So what will be the Norton equivalent circuit you will get? IN current and your RTH, and your RL value will be in parallel. RL value. Okay. So this is your Norton equivalent circuits, and IN value we got 20 divided by 3, and RTH value we got 6, and RL value we have 5. So if you want to convert this particular circuit into Thevenins, what you will do? If you want to convert this particular circuit? So I told you this particular things can be written like this: positive, negative, R, and this is your RL. So this will become VTH and this will become RTH. So RTH will remain same. So VTH will be 20 divided by 3 into 6. So VTH will be 40. And you can draw RTH upside also, downside also, it doesn't matter. 6. That is your RTH. And your RL value is 5. Okay. So from Norton equivalent to directly you can go for Thevenin's equivalent, and from Thevenin's equivalent also you can calculate the Norton equivalent. How you will calculate the Norton equivalence from Thevenin's? So suppose you have RTH value, you have a VTH value, and this is your RL. So you want to convert from the Thevenin's equivalent to Norton's equivalent. What you will do? VTH by RTH. So this will become your current, IN current, that is VTH by RTH, V Thevenin's by R equivalent, and write RTH, not like this, and draw your RTH in parallel to this, and draw your RL. So vice versa, in a both way you can do it. So you understood, guys? Have you understood this thing? Prasanna, is this clear? Priyanka, is this clear? Priyanka, is this clear for you?
Yes, sir. Clear, sir.
Okay, Priyanka, if it is clear, then
Clear, sir.
okay, fine. See, we have one question. You need to develop. Question is, developed the Norton equivalent circuit. Norton equivalent circuit. Okay, Norton equivalent circuit across the terminal X and Y. Across the terminal X and Y. Just wait. Across the terminal X and Y. So suppose you have a circuit like this. This is your positive, this is negative. This value it's given as a 10 volt, and this is your 4 ohm. The current is flowing, IX current is flowing. Okay. And this is 5 ohm. This particular value they had mentioned like this. This is your 2ix. Okay, and this is your X and this is your Y. So you need to find the Norton equivalent. Norton equivalent. So for Norton equivalent, what we have to do? Make the same circuit positive negative 10 volt. This is your 4 ohm. Current is flowing, Ix current is flowing, and this is your 5 ohm. This is 2Ix. Okay. Simply you have to do short circuit between X and Y. And you need to find this IN current. Okay. So what I told you, we can, if if I have a current like this, if I have a resistor like this, I can make, if I is there, if R is there, I can make these things as a positive negative I into R with resistor. So this thing can be replaced like this for a simplification. So we'll get positive negative 10 volt. This is your Ix. This is 4 ohm. So I am making it as a 5 ohm, and this negative, positive means this is positive, that's why it's positive is coming here, and this particular tail is negative, I am assuming negative. 2 into 5, 10 Ix. You'll get 10 Ix value, and this is your IN only. Now you got the simple circuit, very simple circuit. What is the value of Ix? See, apply the KVL here. Minus 10 plus 4, Ix is equals to 0. So 4 Ix is equals to 10. So Ix value is 10 upon 4. Okay. Now apply one KVL here and get the value of IN. Minus 10 plus 5 IN minus 10 Ix is equals to 0. So 10 is equals to 5 IN minus 10. The value of Ix you got 10 upon 4. So if you solve this value, 5 IN will be 10 plus 100 by 4. It is 25 only. So IN value will be 35 by 5. That is 7 ampere. So we got the value of 7 ampere. Okay. We got the value of a 7 ampere. Now for finding the R equivalent, and we have a dependent source, we have to do the same thing what we have done for a Thevenin's equivalent. So we got the IN value. Okay. Now what I am telling, suppose the network is like this. The network is like this: 4 ohm, this positive negative, this is 10 volt, this particular 5 ohm, and because you have a this is 2Ix. So this is your particular network. Okay. This from here you are seeing. So I have a dependent source here. Okay. I have a dependent source here. So for this for this dependent source, for I will assume one test voltage, that is 1 volt, and I am assuming this as a my I current, I dash current, and we are finding the RTH, so we have to do short circuit in this particular independent source voltage. So this will be short circuited. So this is short circuited. So what is the use of this? If this is short circuited, what is the use of this? All the current will flow here only. No current will flow in IX. No current will flow because this is a short circuit. The current will come like this and it will flow in this because it is short circuit. It won't go to the 4. So that means my IX value is 0. If the IX value is 0, then we are getting, this is my 2IX. This particular is a 5 ohm. This is my test source, and here I am getting the Ix value is 0. So it means it's open, and it is also open because it's depending upon this value. So this is my 1, this is my I dash, and this is 5. So I am getting a simple circuit like this: 5 ohm, positive negative 1 volt, and this is my I dash. So what will be? V is equals to I dash into R. So I dash value 1 upon, I dash value will be V is 1. So 1 upon R. So I dash 1 upon R. R value is given as a 5 only. So I dash is, if I dash is 1 by 5, so V is equals to I into R. So R value will be V by I. You will get R value as simple as a 5 volt only. 5 ohm resistance only. So what is the Norton equivalent we are getting? So we got the IN as a 7 ampere current, and our RTH as a 5 ohm. This is our RL load. The same circuit can be, this is our Norton equivalent, and the same circuit can be made to the Thevenins like this. This will be 5 ohm, 7 into 5, 35. So this will be VTH, and this is RL. Both are same. Guys, this part is clear? Priyanka, is this clear?
Yes, sir.
Okay. So now you need to do one question. Let me show you. So question is what? You have to develop the Norton equivalent circuit between the term x and y, so our circuit is like this. This is 10 ohm, this is J2 20, and this particular is, it's 10 at an angle 0 degree volt. This is x, this is y. So you need to find the Norton equivalent of this circuit. So how you will solve it? Same way.
Short the X and Y.
Yeah, short the x and y. Right. So if you'll sort the x and y, so this will be your IN current, right? This will be your IN current. So you need to find the IN current. So how you will find the IN current? So see, What I am telling, if you will short this particular thing now, so it will become redundant. These things will become redundant because all the current will try to come in this. Current always follow the minimum path. So if here it is short circuited, so current, no current will go in this. It will go, it will, current will directly come from here and it will jump from here. No current will come because we are providing one short path, short circuited path.
So
Yeah.
if it is inductance, then that is a reductant only now.
Yeah, anything. If you have any circuit like this, if you are providing one short circuit and here you have a voltage, some resistance, so the current will flow this path. It won't go in this part. So current will be zero in this particular branch. Okay, remember this point. So
Yes, sir.
your current will be zero in this branch. So directly apply the KVL. What current you will get? Minus 10 plus 10I in is equals to 0. So in value is 1 ampere because this branch current will be 0. Okay. Oh, suppose means I miss one point. I'm really sorry. I miss in a question itself. I miss one point. Here one capacitor is given. Okay. One capacitor is also given. The value of that capacitor is minus J10. Okay. So minus J10. It's a capacitor. So okay, if it will be the capacitor also, then the current will be zero because in this particular this is short circuited across this. So you are having a new circuit is like this, 10 ohm short circuited, minus J10, and you have a voltage 10 at an angle 0. So find the value of your current, IN current. This is your IN current. So what the IN current you will get? What is the Z equivalent? Z equivalent will be 10 minus J10. This 10 will be plus to this. So IN will be 10 divided by 10 minus J10. So what you will get? 1 divided by 1 minus J. So IN will be 1 by 2, 1 plus J. After rationalizing, do the rationalizing. 1 by 2, 1 plus J. So you are getting the IN value is this. Okay. So for finding the, now you got the value of IN, and for finding the value of R equivalent, what you have to do? Same thing here. Assume this part is minus J10. So for finding the R equivalent, you have to see from here. Okay. Have to see from here. This will be short circuited because it is independent branch voltage. So if it will be short circuited, now these two are in series. So you are getting, you are watching from here. So these two are in series means 10 minus J10, and this is your inductor J20. So these two are in parallel. So 10 minus J10 into J20 divided by 10 minus J10 plus J20. So Z equivalent you are getting. So after solving this, how much you will get? Take 10 common, 1 minus J, it will become 200 into J divided by, after solving take 10 common, 1 plus J. So this will get cancelled out. So 1 minus J, if you'll solve this, okay, if you'll solve this, what you will get? J plus 1 divided by 1 plus j into 20, j plus 1 into 20. So you are getting this particular things will get cancelled out, this will get cancelled out, it is multiplied with 20. So z equivalent is coming how much? It's coming 20 after solving this. Okay, means like it's a normal calculation, yaar. J 200 plus 200, and this in the downside it's becoming 10 plus j 10. Take 20 common, you will get 10 plus j 10 divided by 10 plus j 10. So this means your z equivalent is coming how much? 10. So what is the Norton equivalent? You got the IN value, you got your ZTH, and this is your load, which is not given. Load ZTH value is coming how much? Z equivalent is coming 20. And what about your Norton current? Norton current, you got 1 by 2 1 plus j. IN is 1 by 2 into 1 plus j. And if you want to find from this your VTH, you have to multiply to this. So ZTH will be 20 and your VTH will be this multiplied by this, you will get 10 into 1 plus j, and your load will be this. Understood, Priyanka?
Yes, sir.
Okay. So what I taught you now, I already means the next topic is what you need to study. I already taught you. This is known as a source transformation. Source transformation. So source transformation means if you have RS, if you have positive negative Vs, if you want to make the circuit in a current, so you can draw the circuit Vs by Rs, and this is your Rs. So this is the source transformation. Okay. In the same way, RTH was equals to Rn is equals to VTH divided by IN. Okay. If you have a Thevenin's voltage and if you have a Norton current, if you will divide both this, then you will get the RTH value. Okay. So, and if you have a current source like IS here, and if you have a voltage resistance RS here, you want to make the voltage in the form of voltage, you can take it like this: plus minus IS into RS into with RS. Okay. So this is the source transformation concept. Now the next question is, you need to find the power in 5 ohm resistor. Okay. So question is, you need to calculate power in 5 ohm resistor. So your circuit is like this. This is your 5 ohm, this is your 10 ohm, this particular is 4 ohm. From you have this as a 5 ohm, and this is your 4 ampere. So how can you do it? Means you need to find the power across this. So a lots of method is there. If you will find the value of means option A is 0 watt, option B is 40 watt, option C is 80 watt, and option D is 120 watt. So even if you'll find the value of a I current na, you can easily get the value. You can do with the superposition theorem also. Means not with the superposition, means you can do with the superposition theorem by finding the value of a current and just do I square into R. Or you can do with the VTH into RTH formation. So I am just trying with the VTH form. Okay, we'll learn the Thevenin's, or we can go for a Norton equivalent also. So we'll go for the Norton equivalents. Okay. So suppose this is my load. So they are asking about the 5 ohm resistor na. So I am just thinking this is my load. Okay, this is my load. So if this is my load, then what I will do? I will short circuit IN, and this is my 4 ampere, and this is 10 ohm. This particular is your 4 ohm. This is your 5 ohm. Okay, so how you will find the value of a IN? So if you short circuit, means this, okay, this 4 ampere current is flowing from here. So some current will also come from this side, right? Some current will also come, and this is your 0. This voltage is 0 because I am taking it's a ground. Okay, this will be 0 only. So you need to find the value of this particular current. Okay, I am taking this as a V. So just apply the nodal analysis. V minus 0 divided by 10 plus V by 4. V minus 0, this will be equal to 5. So 4V plus 10V is equals to 5 into 40. So you are getting 14V is equals to 5 into 40. So V value is 5 into 40 divided by 14. So V value you got. So what is this current? 5 into 40 divided by 14 divided by 10. V minus 0. V minus 0 divided by 10. So this current is coming like this. 20 by 14. So what will be the IN current? IN current will be 4 ampere plus 20 by 14. So 14 4 ja 56 plus 20 divided by 14. So how much you are getting? 76 by 14. You got the IN current. So now find the R equivalent voltage. If you need to find the R equivalent voltage, so this is the circuit, and you are watching from this side. Okay, and this will become open circuit because current will become open circuit. This is 10. This particular is your 4, and this will also become open circuit. Current will become open circuit. So what is the R equivalent? R equivalent you are watching 10 plus 4, 14. R equivalent is 14 only. Now you got the value of IN. IN value is 76 by 14. You got the value of R equivalent. R equivalent is 14. And you got the value of your RL value, load value. Load value was how much? Load value was 5. This is your 5. And you need to find the power across this. You have the circuit, you form the circuit like this. So what will be the VTH? Even you can do with the VTH. So VTH formation will be positive negative 76 volt. This will be 14. And this particular is your 5. So overall current will be how much? Overall current will be I is equals to 76 divided by 19. Okay, so 19 into 4. 19 into 4 is how much? 76. So this I current is flowing as a 4 ampere. So what will the power? Power is equals to I square into R. So 4 square into 5. So 16 into 5. That is 80 watt. So you will get 80 watt as the answer. So we do like this. You can do with the help simple calculation. You can do with the simple calculation like this. V1 take V2 and get the current in this branch. If you'll do with this concept also, you will get the same result. See, I am applying the nodal analysis here. 4 ampere is equals to V1 by 5 plus V1 minus V2 by 10. So 40 is equals to 3V1 minus V2, one equation. Do another equation in this. V2 minus V1 by 10 plus V2 by 4 is equals to 5. So 4V2 minus 4V1 minus 4V1 plus 10V2, 80. What will be the result? 14V2, right? 14V2 minus 4V1 is equals to 80. And solve the value for V1, V2. This will be 14. 4V2 plus 10V2. 14V2 minus 4V1 is equals to 80. Okay. So 14V2 minus 4V1 is equals to 80. So we need to find the value of a V1. So that's why I'm just cancelling the V2 part. So if you'll cancel the V2 part, okay, 7V2 I am taking, minus 2V1 I am taking, and this will become 40. If I am cancelling the V2 part, just multiplied here 7V2 plus 21V1 280. So this will get cancelled out, will get 19V1 and 280 plus 320. So V1 value you are getting 320 by 19. Okay. You are getting the V1 value as a 320 by 19. So get the value of a I current, 320 by 19 into 5. So 5 into 2. So you will get 64 by 19. Okay, I think we did some mistake here. That's why, because the value will get cancelled out. See, KVL equation will be 4 V1 by 5, V1 minus V2 by 10. After solving this, this will be 2V1, 3V1 minus V2. Okay, this equation is fine. And V2 minus V1 by 10 plus V2 by 4 is equals to 5. Okay, while solving this, 4V2 minus 4V1 plus 10V2, and this will become, it won't be 5, it will become 20 na. It will become 20. See, 40 into 5, so 200, it will become 200. We just did a mistake here, it will become 200. Okay, this part we did calculation mistake. Okay, that's why try to calculate. Yeah, so 4V2 minus 4V1 plus 10V2 is equals to 520, 200 you will get. So after solving this, you will get 10V2 minus 4V1 is equals to 200. So 14, it will become 14. So this you get after adding. So 7V2 minus 2V1, you will get 100. And while multiplying the 7 in this equation, we are getting minus 7V2 plus 21V1, 280. Okay, so while solving this getting cancel out, 19V1, this you are getting 380, and 19 into 2. So V1 value you are getting 20. Directly you are getting the V1 value 20. And what is the power? Power is V1 square by R. So you got the voltage across this particular branch, that is your V1. Do the power calculation, that is 20 into 20 divided by R is 5. 5 into 4, you are getting 80 watt. So like this way also you will get the value of 80 watt. And by this way also you can do it. So it's up to you how you want to calculate the power. Okay, is this clear, Priyanka?
Yes, sir.
Okay, so okay, two topic is remaining, we'll see it tomorrow. Then your theorems will be completed tomorrow. Okay, compensation theorems and all everything. And after that we'll go for maximum power theorem. So hardly 2 3 classes will be required for this part. And after this we'll move to the transient. That is a very important part of the network theory. Transient is the last chapter also for a network. No, after transient you have one more chapter, that is graph theory. Graph theory means in a graph theory very less amount of questions they are asking. And Laplace and all we will see in signal system and control system. Okay, even if we will do the Laplace and resonance part here, but it will be very less. So you are getting means Priyanka, you are able to understand these things, or you watching the recorded videos. You watch the recorded videos means whatever the topics you are not able to understand.
I understood, sir.
You understood na? If you are facing means like if you guys are facing any problem na, any problem you can ask, because the concept, this is the basic
Sure.
building na, so you need to very concentrate in this part. Okay.
Yes, sir.
Okay, so we'll meet tomorrow. Bye.
Yeah, okay, sir. Bye.